Use the data in the following table, which lists drive-through order accuracy of popular fast food chains. Assume that orders are randomly selected from those included in the table. First thing is that we always add the columns and the rows and then find the total overall. If we add column A for restaurant A, 337 plus 36 gives us 373. Column B, 274 plus 56 gives us 330. Column C, 233 plus 32 gives us 265. Column D, 130 plus 15 gives us 145. Now we want to find the total in the row. So for order accurate, we're going to add up those four numbers to get a total of 974. For order not accurate, we're going to add the total of those four numbers to get that number, which is 139. The entire total is either adding this last column or the last row, which gives us 1,113. Now the question states, if two orders are selected, find the probability that they are both from restaurant D. So how many do we need to look at? So we need to look at the numbers that are associated with restaurant D. Well, the total for restaurant D is 145, and the entire total is 1,013. Okay? So for the first part, it says since they want both, that means we're going to have to select two from restaurant D. Now it says assume that the selections are made with replacement. Are the events independent? Okay, so assuming for part A, to find the probability that event A occurs in one trial and the event B occurs in another trial, we multiply the probability of event A by the probability of event B. But be sure that the probability of event B is found by assuming that event A has already occurred. And this approach is reflected in the formula below. Probability of A and B is equal to the probability of A times the probability of event B, provided that A has already occurred. Now in this situation, the simple event is selecting an order from a restaurant. Now when selecting an order from a restaurant, we know that there are a total of 1,113 different orders from which to select. Now we want to count the number of orders from restaurant D, which is the fourth column, which we did, and we get 145. Therefore, there were 145 orders from restaurant D. Now, what we're going to do is divide the number of orders from restaurant D by the total number of orders to calculate the probability that the first selection is from restaurant D. So, the probability of event A is equal to the total restaurant D orders, which is 145, divided by the total, which is 1,113. Now, recall that in this case, the first selection is replaced before the second selection is made. Therefore, the events are independent, and the probability of event B stays the same regardless of the outcome of event A. So basically what we're saying therefore is probability of B is the same as probability of event A, which is 145 over 1,113. Now, since we want to find, back up in the question here, it says that they are both from restaurant D, so that means we're going to have two probabilities that we need to multiply. So we're going to multiply the probability of event A by the probability of event B to obtain the probability of A and B, and then occurring, and then rounding to 4 decimal places. So we have the probability of event A and probability of event B is 145 over 1,113 times 145 over 1,113. And here is our decimal, and then we're rounding it to 4 decimal places. So we need to round this 7. This is going to round that 9 up, which then change that 6 to a 7, which gives us 0.0170. And therefore, assuming the selections are made with replacement, the probability of getting 2 orders from restaurant D is 0.0170. Now, the events are independent because choosing the first order does not affect the probability of the choice of the second order because they are independent, and because of the fact that since they're independent, it was with replacement. So with replacement gave us that result. Okay, so now let's take a look at part B. Assume that the selections are made without replacement. Are the events independent? Okay, so again, there's our question. Now, the probability of event A will be the same as the probability of event A in part A. So we would say that the probability of A, which is equal to the total restaurant D orders over the total, is equal to 145 over 1,113. Now, when replacements are not used, the events are not independent, and the probability of event B changes depending on the outcome of event A. Since event A was selecting an order from restaurant D, and the selected order does not get replaced, the number of orders from restaurant D and the total number of orders to choose from each decrease by 1 when choosing event B. So therefore, we know that the probability of event A is equal to 145 or 1,113, and the probability of event B, provided that A has already occurred, we're subtracting 1. Disregard those two equal signs. It should be just 1. So we're subtracting 1 from 145, which gives us 144. And subtracting 1 from 1,113 gives us 1,112, because we've already picked the probability in here, and since it's without replacement, that's why you're losing one value from each, the numerator and denominator. So now what we're going to do is multiply the probability of event A by the probability of event B, given that event A has occurred, to obtain the probability of A and B occurring. And then we're going to round our answer to 4 decimal places. So the probability of event A and B is equal to 145 over 1,113 times 144 over 1,112, which gives us the following decimal, and we're going to round this to 4 decimal places. So this becomes 0.0169, because that 7 rounds that 8 up. And therefore, assuming the selections are made without replacement, the probability of getting 2 orders from restaurant D is 0.0169. Now, because of the fact this is without replacement, we would then say that these events are not independent, because choosing the first order affects the probability of the choice of the second order.